Hello friends, today's question. A circular disk of radius b has a hole of radius a at its center. In the figure, if the mass per unit area of the disk varies as sigma naught upon r, then the radius of gyration of the disk about its axis passing through the center. So this is a disk having a hole of radius a and the disk is having radius b. Okay. We are going to find out its radius of gyration. Okay. So we know that radius of gyration, it is given as mk square, which is equal to moment of inertia, where m is the mass and k is the radius of gyration, and that is given as mi, moment of inertia and radius of gyration. And in this case we are supposed to find out about the axis which passes through the center. Radius of gyration about the axis which passes through center. And we consider, let us suppose this is our disk that is given. A is the area of the disk which is removed, B is the outer area, radius, and in this case we consider a circular disk of radius r and mass dm. So this is a disk of radius r and it is having a mass dm. Consider a disk of radius r and mass dm. So for this disk we can write the moment of inertia. The moment of inertia for this disk is given as di, and di will be equal to dm r square, and which can be written as sigma 2 pi r square dr, and mass per unit area is given as sigma naught upon r. So therefore di will be equal to sigma naught upon r multiplied by 2 pi r, and this will be r square into dr. R and r cancels out, so we get this as 2 pi sigma naught r square into dr. Next, we found out that for this is small mass dm and having radius dr, the moment of inertia is di. Therefore, moment of inertia for complete disk after removing disk of radius a. So let us suppose that is given as I. So you can see I will be equal to integration. Limits of integration are going to vary from a to b di. So this will be equal to 2 pi sigma naught is a constant. So we get from a to b, this will be r square dr, and we integrate it, get 2 pi sigma naught r cube by 3, and this is from a to b. Therefore I is equal to 2 by 3 pi sigma naught, and this is our p cube minus a cube. So this is the moment of inertia. we are also supposed to find out the mass of the remaining disk. Okay, so you can say mass of the remaining disk is equal to capital M, which is integration of dm from a to b, and we already calculated partially dm, that is from a to b. This will be equal to our sigma naught upon r multiplied by 2 pi r into dr, and this r cancels out, so we get mass m is equal to 2 pi sigma naught is constant, and this will be from a to b dr, which gives us 2 pi sigma naught b minus a. So we got the mass, and formula we already know, that is radius of gyration. We get this as mk square is equal to I, and mass is 2 pi sigma naught b minus a multiplied by k square. Moment of inertia we found out as 2 by 3 pi sigma naught b cube minus a cube, and here 2 pi sigma naught cancels, and for b cube minus a cube we are going to expand it, so this will be b minus a, k square is equal to 1 by 3, this comes b minus a, b square plus a square plus ab, and here also b, this cancel, b minus a cancels out, so we get k is equal to square root of b square plus a square plus ab divided by 3. So this is our radius of gyration. This is radius of gyration. Okay, and from the option available to us, we get this as option number C is the correct option. Okay, we can say option C is correct. Here we cannot use the direct formula that moment of inertia of the complete disk minus moment of inertia of the removed disk, because here the mass per unit area varies as sigma naught upon r. So because of this additional condition, we have to stick to the basic method of calculating the moment of inertia. Okay. This completes the question. Thank you.